Okay, welcome to lesson 3 of periodicity. Now the focus for this lesson is ionic size and how that changes across the periodic table. So there are two types of ions. Remember, there are the positives and the negatives. The positives are called cations and the negatives are called anions. Now cations form as a result of losing electrons. So just to explain that, if we take lithium as an example, lithium is the third element. It has a configuration of 2.1. Now we should be writing this in subshell configuration. So it's 1s2, 2s1. Okay, lithium loses that outer shell electron, and in so doing ends up with a configuration of 1s2, 2s0. So now it has 2 electrons left, but it's the third element. It has 3 protons. So you can see as a result it has an overall charge of 1+. All cations form as a result of losing electrons. Now the other thing to realize is that in losing that electron, it loses its outer shell. And so losing that outer shell makes it smaller than the original atom. Metals are the elements that tend to form cations, because metals are the elements that have few electrons in their outer shell. In this case, lithium had 1. And also, they are the larger atoms, because I don't know if you remember, as you go across the periodic table, the size of the atoms progressively gets smaller. And so if we just concentrate on one period, the metals that are on this side of the table are the atoms in that period that are the larger atoms. So they're the ones that hold the electrons less firmly, and they're the ones that therefore tend to lose the electrons. So the metals tend to form cations. And moving on to the next slide, anions, negatively charged, they form as a result of gaining electrons. Now if we look at fluorine as an example, it's element number 9. It has a configuration of 2.7, which we should write as 1s2, 2s2, 2p5. This element gains an electron. An electron will come in and form a configuration of 2s2, 2p6. So it now has 10 electrons. It still has 9 protons, so it now has a charge of 1-. So anions form as a result of gaining electrons. And in gaining electrons, they get bigger. And the non-metals are the chemicals that tend to gain electrons, because as we saw in the previous slide, remember the atoms on the left were larger than the atoms on the right. These on the other side of this zigzag line are the non-metals, and because they're smaller, they have a stronger attraction for electrons. All electrons tend to go from these bigger atoms to these smaller atoms. And so the smaller atoms, the non-metals, are the chemicals that tend to gain electrons. Okay, so that's a general summary of ionic size. In a little bit more detail, let's look at some of the trends. So as we said, metals lose their electrons, and in losing their electrons there are now more protons, and those protons have now a greater proportional pull on the electrons, and that draws the electrons in closer to the nucleus. So the cations get smaller. In the image here below, the original size of the lithium atom is probably that. Beryllium, there's boron, there's carbon, there's nitrogen, oxygen, fluorine, progressively getting smaller. Okay, as you go across the period. So you can see here that the lithium atom is much larger than the lithium ion. In fact, the lithium ion has formed as a result of losing the outer shell electron. Now, when we compare the nonmetals, with the exception of carbon here, right? When we compare the nonmetals, so nitrogen, oxygen, fluorine, we can see that the ions have increased as we move from atom to ion. Now, the nonmetals, they gain electrons. In gaining electrons, there is now less protons per electron, so there's less proportional attraction per electron. And if there's less proportional attraction, then the electrons can extend further out from the nucleus. The ion gets bigger. Right, so in general, cations are smaller than anions, and certainly cations are smaller than their individual atoms, than their original atoms, but the anions are larger than their individual atoms. Okay. Now, isoelectronic ions, isoelectronic means that they have the same number of electrons. So when we look at the electronic configuration of all of these ions that are shown on this slide, they all have a configuration of 1s2, 2s2, 2p6. They are all isoelectronic with neon. Okay, sodium had 11 electrons. It's now at 1+ ion, so it's lost those 11 electrons to produce 10. 2, 4, and 6 is 10. Fluorine had 9 electrons. It's gained 1 electron to produce 10. So it has a configuration of 1s2, 2s2, 2p6. All of these ions are exactly the same. But the thing that's changing, the number of electrons remains constant. The number of shells remains constant. There's one main shell, a second main shell, the number of subshells remains constant. But the thing that's changing is the number of protons, the nuclear pull. So nitrogen is element number 7. It has 7 protons. Oxygen is element number 8. It has 8 protons. 9 protons, 10, 11, 12, 13. So the trend in ionic radius here is clearly dependent on the nuclear charge. So isoelectronic ions, in order to make a judgment about the comparative size of the ion, you need to be looking at what's in the nucleus. It's the nucleus that determines the overall attraction. Okay, let's finish off with a question. This is a typical exam question. When the following species are arranged in order of increasing radius, what is the correct order? Now again, they are all isoelectronic. You should be able to identify that. Argon, they're all isoelectronic with argon. Argon has a configuration of 1s2, 2s2, 2p6, 3s2, 3p6. Okay, it's element number 18, and that's its configuration. Potassium is element number 19, but it's lost an electron, so it has 18 electrons now. Chloride is element number 17. It's gained an electron, so now it has 18 electrons. So they all have 18 electrons. They are isoelectronic. So what we should be looking at, as we saw in the previous slide, is the nuclear charge. Okay, and if we're going to arrange them in order of increasing radius, we have to start off with the element that has the highest nuclear charge, because that will draw in the electrons much more closely, moving to the element that has the lowest nuclear charge. And so in order of 17, 18, 19, this is an increase in nuclear charge. This would result in a decrease in radius in the order in which they're shown. But in B, we can see that we have 19 electrons, 18 electrons, 17 electrons. As the nuclear charge decreases, The ionic radius increases. So this is the correct answer, B. Okay, and that's enough for this video.